So beginning of chapter 8, we're going to discuss polynomials. And in general, in chapter 8, we're going to learn how to add, subtract, multiply, and not divide yet polynomials. We're going to learn some special features of polynomials. First thing we need to do is define a polynomial. And your book's definition is it is a monomial, or the sum of monomials. When we get to Algebra II, we're going to shift that definition a little bit and call it a power factor, or the sum of power factors. And you'll see why in just a second. So to define a polynomial in terms of monomials, we need to know what a monomial is. And a monomial, by your book, is a number, a variable, or the product of one or more numbers and variables with whole number exponents. Please note that in Algebra I, we are only dealing with whole number exponents. So our whole numbers are 1, 2, 3, 4, 5, and including 0. However, when we get to power factors, we're going to let the variable, the number portion, can be anything up to a complex number. So the first part of Algebra II, we are going to keep the constant number as a real number. And where it said whole number exponents for a monomial, we're going to be able to do things with rational exponents, real number exponents, and stuff like that. So for our purposes right now, we're going to so in Algebra 2, we're going to be able to use complex numbers. Right now, we're going to use real numbers. In Algebra 2, we're going to use real number exponents. But for right now, we are going to use whole number exponents. And that is our integers, our positive integers, and the number 0. So power factor is any number that has a number times a variable raised to a power, where that's a real number, and that number is a positive integer. So we need to determine whether or not things are power factors or monomials. So that's the first thing. This would be a power factor, where the number in front of the variable is pi, and the variable is the number, the power is the number 2, and the number 2 is a positive integer, and pi is a real number. So that would be a power factor or a monomial. This next example, the square root of 2x to the negative 1, is not a monomial or a power factor. The square root of 2 is good. That's a real number. Even though it's irrational, it's real. However, the exponent is not 0 or a positive integer. We have a negative integer here, so this is not a polynomial function. In Algebra 2, we'll figure out what kind of function this is. Another non-example for a monomial or a power factor would be the square root of negative 4 times x cubed. In Algebra 2, you're going to figure out that we get imaginary numbers anytime we take an even root of a negative number. So we no longer have a real number here. You cannot give me two real numbers, or one real number multiplied by itself that gives you negative 4. Because if I have a negative times a negative, I end up with a positive. And if I have a positive times a positive, I end up with a positive. So this does not make sense in the real number system. Okay, that is a positive integer, so that one would work. The problem here is that that is an imaginary number. So that's what monomials are, and some examples of monomials. Next thing I want to talk about is the number that's in front of it is called the coefficient. And the power that it's raised to, since I'm using 0 or positive integers here, that power is called the degree. Okay, and that's assuming that I have a single variable here. So some examples. 3x to the fifth. The coefficient would be 3. The degree would be 5. Negative 4x squared. The coefficient is negative 4. The degree is 2. So we need to be able to identify coefficients. And I misspelled coefficient. And the degrees. And you got to remember that in order for it to have a coefficient or degree, it actually needs to fit in the term of monomial or power factor. So far, I have shown you only examples that have a single variable. There are polynomials of multiple variables. For example, x squared y cubed, with the number 2 in front of it. This would still have a coefficient of 2. But the degree is the sum of the powers of every variable. So the degree in this case would be 2 plus 3, which is 5. Another example. Square root of 3xy cubed. The coefficient is the square root of 3. And the degree, in this case, well, x is to the first power times y cubed. So that would be third power plus first power is fourth, so it would be of the fourth degree. Another special type of monomial is one where the variable is to the 0th power. And we know that a number except for 0 raised to the 0th power is 1. So if you just see a constant number, it still has a variable multiplied by it, but that variable is to the 0th power, and in this case we would call it a constant term. Okay, so now we know pretty much about monomials. Now let's turn them into polynomials. We said that the polynomial is the sum of monomials. So what I'm going to do is I'm going to put a whole bunch of monomials together. And this would be a polynomial because each of these items here are monomials. So it's a sum of each one of these 4 monomials. Notice I have a negative sign here, but that negative is the same thing as plus the opposite of that number. Same thing here. So I do have a sum of all of these things. We want to write it in what is called standard form. We write it in decreasing degree order. So we find the monomial with the highest degree and we write it first. And that would be this one, negative 3x to the fourth. Then the next term would be the square term, plus 2x squared. Then the x term, and then the constant term. When a polynomial is in standard form, the coefficient in front of the first term would be called the leading coefficient. And the last part would be called our constant term. So you're going to have a group of problems where they're going to ask you, is it a polynomial? And if so, to write it in standard form, identify the leading coefficient and the constant term. If it's not a polynomial, tell me why it is not a polynomial. And basically what you're going to do is you're going to find where either the coefficient is an even root of a negative number or the exponent is not a positive or zero integer. So that gets us through the definition of what a polynomial is. One other thing I want to point out here is that the degree of the polynomial is the highest degreed monomial that makes up the polynomial. So in this case, this would be a fourth degree polynomial. So the next thing we're going to do is we are going to classify polynomials further by their degree and or their number of terms. Please note that something that's the third degree and something that has 3 terms could be 2 different types of polynomials, and we'll get to that after I erase the board. So the next thing we're going to learn how to do is to classify polynomials by their number of terms and by their degree. So first thing for number of terms. If a polynomial has 1 term, it is called a monomial. And things that have 1 terms are like 2, 3x cubed, negative 4x to the 5th. Each of these have single terms, okay? And they're single terms, so they are called monomials. Something that has 2 terms is a binomial. An example would be x plus 5, 3x cubed minus 2, negative 4x squared minus 4. How about 3x to the 5th plus 2x? Basically, anytime you have 2 terms, it is called a binomial. Something that has 3 terms, we call a trinomial. Example would be 2x squared plus 3x minus 5. In general, anything that has 4 or more terms, we call a polynomial. Just call it a polynomial. So the ones that we are really concerned about are monomial, binomial, and trinomial. And we get those by counting the number of terms. Now, for classifying by the degree of the polynomial, remember the degree is the highest powered term. The highest powered term is 0. For example, 3x to the 0th, which we know is 3. It is called a constant function because when we have x to the 0th, that x to the 0th is 1, so we just end up with the constant term that's remaining. The highest degree is 1. The name of the function is linear. For example, 2x plus 5, negative 3x. Each one of these are linear. Highest degree is 1. Anything that has a power of 2, we call quadratic. Examples would be x squared, 4x squared minus 3x, 2x squared plus 5x minus 5. Notice that the number of terms and the degree don't necessarily have to correlate. So this one would be a quadratic monomial, a quadratic binomial, and a quadratic trinomial. If the highest degree is 3, we call it cubic, and that would be like x cubed. Negative 4x cubed plus 5x squared minus 2x plus 3. Highest power is 3. so we call it cubic. We can continue on with like quartic and quintic. However, they typically, anything after 3, if it's an even number, we just call it an even polynomial. And if it's odd number, we call it an odd polynomial of the nth degree, where n is equal to the degree of the polynomial. An example here would be x to the 7th plus 6x minus 5 would be a 7th degree odd polynomial. And we're going to see in Algebra 2 why these are classified as even and odd polynomials. But besides just having these numbers, there is another reason for calling these even and odd, besides these being even and these being odd. It just happens to be how their graphs look. So this is how you classify polynomials based on the number of terms and the degree. The last section for section 8.1 is we're going to cover how to add and subtract polynomials. To add or subtract polynomials, we are going to combine like terms. And something is a like term if it has the same variable to the same degree. So what we're going to do is we're going to come up with the monomials. We're going to find the ones that have the same variables to the same degrees, and then we are going to combine them. There are 2 ways to do this. One is going to be the horizontal method, which I'm going to do both of these problems using the horizontal method. Then the second method is to use the vertical method, which lines up just like regular addition and subtraction. So what I'm going to do here is I'm going to take the first monomial, which is a second degree monomial, and find every other second degree monomial and do the mathematical operations on it. So I have h squared plus 5h squared is 6h squared. Then my next monomial is 4h. It says 4h plus a negative 8h is 4 minus 8, which would be negative 4h. And then for my constants, I have negative 4 and 2. Negative 4 plus 2 is 2. So you find the ones that have the same degree and you combine them. And when you get all done, you want to write your polynomial in standard form, which is highest degree first, descending, and this one already is that way. So what I'm going to do is I'm going to look for the highest degree term on the left, and that's negative 6p cubed. I have p cubes over here. Negative 6 minus 7 is negative 13p cubed. So I'm going to go for my squareds. I have 9p squared, negative 3p squared. 9 minus a minus 3 is 9 plus 3, which is 6p squared. Then my first power terms are negative 11 and 0. So I'm just going to add the negative 11. And finally, my constant terms, I have 3 and 4. 3 minus 4 is negative 1. What I will warn you about is if there is a subtraction between polynomials, this is where students mess it up. They'll get the first term right, but all these others, they forget to distribute the negative sign. So another way to think about this problem is get rid of unnecessary parentheses. This first set of parentheses just has a positive 1 in front of it, and 1 times the number is itself. This second set of parentheses has a negative 1 in front of it, so just multiply everything in here by negative 1. So I have negative 7p cubed plus 3p squared minus 4. And then we could go about combining our like terms like we did before. The first ones were negative 6 and negative 7, which was negative 13p cubed. Then we had 9 plus 3. And I messed up here. So I have 9 minus a minus 3 is 9 plus 3, which is 12. See how I told you you can mess it up? So I end up with 12p squared. My next terms are this one, which is negative 11p. And then my constant term is 3 minus 4, which is minus 1. So, yep, even I messed this up because I did 9 minus a minus 3 and just subtracted the 3 the first time. So my recommendation is you distribute it out first. The final method that I want to show you is the horizontal method, which I find students get the answer correct more than they do in either of those two methods. And you just write each polynomial in standard form, aligning the powers above each other. And then you do the mathematical operation. 4 plus negative 4 plus 2 is negative 2. 4 plus negative 8 is negative 4. 1 plus 5 is 6. And notice I get the same answer. Same thing here. Write it in standard form. Negative 6p cubed plus 9p squared minus 11p plus 3. Here I've got a 7p cubed, a negative 3p squared, nothing with a p, and plus 4. And if I subtract, I put parentheses around it with a minus sign, and I just do the math. 3 minus 4, negative 1. Negative 11 minus 0, negative 11p. 9 minus a minus 3 is 9 plus 3, which would be 12p squared. And negative 6 minus 7 is negative 13p cubed. So notice, after I fix this one, did this one by distributing, did this one vertically, I end up with the same answers for all three of them. I do not care which method you use, just don't come up with a mistake like I did here. Okay? And I purposely did this mistake because that's where you're going to make your mistakes. Okay? So be careful with the negative signs. When you get down here where you've got negative 13p cubed plus 12p squared minus 11p minus 1, another place where students make errors is they try to combine these things. I cannot combine these because they have different powers for the variable. For example, I'll have some students give me negative 1p to the 5th here because they'll do the negative 13 plus 12 is negative 1, and p cubed plus p squared they think is p to the 5th, but it's not. This is wrong. So be careful when you're adding and subtracting. Remember, you can only combine like terms, and a like term has the same variable to the same degree. Last thing I'm going to do is I'm going to put 2 example problems up on the board. You need to do those 2 example problems, and at the beginning of class tomorrow, we will grade those 2 example problems for part of your homework notes grade. So here are the 2 sample problems. They were provided to you on a half sheet of paper at the end of class if you are watching this video in the correct order. Or you can just copy these two problems down and turn them in on a separate sheet of paper at the beginning of class tomorrow. The first one is 5x cubed minus 2x plus 3x squared plus 4 plus the quantity 2x to the fourth minus 3x squared plus 3x cubed minus 2x plus 5. Again, I'm not going to work these out. You're going to see the answers tomorrow in class. The second example is the quantity 2x cubed plus 3x squared. Correction, 2x cubed minus 3x squared plus 4x plus 1 minus the quantity 4x cubed minus 3x squared minus 4x plus 3. So that's the end of section 8.1. Please note that it was a little longer than what's in the book because I needed to cover some items that you should have covered previously that I was not sure whether or not you had covered. So please make sure to have your notes ready and these two example problems done for the beginning of class tomorrow.